Oh, hi. I was just reading about the wonders of momentum. Momentum is inertia in motion. It's this crazy thing. Solve for it. P, which is momentum, vector quantity, is mass times velocity. You can also get it from the units. Kilograms times meters per second. Ugh, momentum's just so cool. There's so much fun stuff that you can do with it. It explains so much of the world. Momentum caused, you might ask. Is it magic? Something else? Another thing? Well, you're wrong. It's an impulse. An impulse is pretty much an applied force. Now, the way you solve it is by taking P, momentum, the finally, minus the initial momentum. But that's not all. You can make it equal force times time. It's incredible. It's amazing. It's physics. Hi. I'm just thinking about collisions. Wham! Collisions are when two things collide with each other. During collision, momentum is always conserved because of the conservation of momentum law. One type of collision is an inelastic collision. It's quite unique. It's when you take two objects that are colliding and add them together. You start off with the basic equation of the momentum of the first object initially, plus the momentum of the second object initially. These, they add together. So you'll take the masses of the two objects and the velocity final, and that'll equal the initial momentum. Because momentum's just cool like that, and it's conserved. Boom! These types of collisions is when there are one large object or two small objects with a common velocity. They may be at rest, and then they burst apart when applied with a force, and they have equal and opposite momentums. The way you solve for this is when you add the first and the second mass together, and then multiply it with their common velocity, which will equal its momentum, will equal the momentum of the first object, final momentum, plus the second object's momentum. They're just so cool, you know. It's conserved in this though. That's why it's just so cool. Physics. Collision is an elastic collision. Now, these collisions are super cool because not only is momentum conserved, but kinetic energy is too. So the only way you'll actually see this in like real life is when in the nucleus of a subatomic particle. If only we lived in a perfect physics world, then everything would be like this. But it's not. To do this, you need not one, but two equations. The first one is when you take the momentum of the first object plus the momentum of the second object, and this will equal the final momentum of the first object plus the own momentum of the second object's final momentum. But that's not all. You also have a kinetic energy equation. It's nuts. After doing some mathematics, which is useful during physics, you'd end up with the velocity initially of the first object minus the velocity initially of the second object. This will thus equate to the opposite of the first object's final velocity minus the velocity of the second object's final velocity. You gotta do some math to figure this out. So use those calculators. Physics! That was